Yeah, so welcome to this session on NSO-ARC and CX Test Automation Manager. So thank you very much to the previous speaker, Maciek. Basically, he set this up perfectly for me. So I'm not gonna have much slides, but basically, my name is Mikael Tidemar. I'm a CX delivery software architect. So what do? I deliver projects all over Europe for different service providers, basically the big providers in Europe. Currently working with Swisscom, and I can happily tell you that NSO-ARC, my baby, has been sold as a services attachment to actually the Swisscom in Switzerland. So that's very good. And next to me, I have Erico. Some words.
Yep. Hello, everyone. So I'm also working with Swisscom with him, and that's why we came together with this presentation. So my background comes from the research world, and that's why when I moved to CX, I started to focus more on testing. Kind of natural, keep a bit my hands on those bad stuff, let's say. What we're going to do is also, I think, answer a bit your last question that you said, what, how, and why, and what we can do, let's say, manual testing, manual running, not only CI/CD, and how that is integrated with the pipeline as well. So how the automated world come together with the physical world as well.
Yeah, and I think that since we had such a nice introduction to CXTM, I'm just going to jump directly to the demo and not waste any more of your time on slides. Maybe we will have time for slides at the end, but we'll see. So I'm just going to jump out to my terminal. Okay, still escape from that one. Maybe some size increase for readability. All right. Hope it's visible for everyone, and let's get started. So what I want to start by showing is that basically this is my project. There's only one project currently in CX Automation Manager. There's my project identifier, and the technology here is orchestration of NSO. Currently there are some login required. There are no test cases. It's an empty project. All right. So in my NSO CLI, I have some configuration for CXTM, but it's empty. And I have something for CXTA as well. Sorry. It's also empty. So let's quickly fill in some stuff. I have something prepared for this, of course. Error on line 1. Okay, I didn't copy paste properly, so a real failure. Okay. Let's try that again. Now it looks better. Okay, so now I've actually added my API key for my own CXTM instance, and this is local, and you can set up any number of CXTM servers if you have one for different environments, or if it's one CXTM server handling all environments in the same place. So that's why I have this CXTA config. So you can have end-to-end environments, integration environments, NSO local, all of those with different topology or testbed YAML files. So basically my NSO local just uses the local 127.0.0.1 localhost address to talk to my own NSO instance running on my machine. But you can have an integration environment with its own IP addressing, its own passwords, and all those usernames and stuff configured already in your... Yes? I hope so, but we will get to more details. So yeah. So basically, CXTM is on my local machine. It's running in containers, but you can run it in any server environment. Just it's a Docker. What is it?
Yeah, it's more than a Docker container.
Yeah, it's
multiple containers put together and can be run typically in the cloud or on your machine or VM or whatever.
All right, so now I have some nice things. So NSO-ARC is a package. It exposes actions, specifically this ARC action. So I can do nice things here. I can do get from CXTM. And I need to specify which CXTM I want to get from, and that's what I just set up, the local one, CXTM local. And what do I want to get from CXTM? There are some choices here. So I want to get all projects. And I run the action, and I get some success. So I'm gonna check what I got. So I got my Acme project. So this is a test project, and I have a start date and an end date. There's an owner and so on. Yeah, there is a lot of information you can set up. But basically, this is what what allows me to talk to CXTM properly from my test case generation. Because what NSO-ARC does is generate test cases based on your NSO CDB. So if I go and check what services I have on my NSO instance, I can check sync all the services like this. And here we have a list of service instances. The first of which is a nano service, which is a kind of sample service, which is delivered with NSO. If you want to check it out, it's in the ncs.examples, the NCS examples folders. I think the number is 20 nano services. So that's something you can try out and learn from if you want to learn how to do nano services. Then we have some other services like this stacked service, which is actually configuring two services, this router static service and this VRF service. So it's a stacked services model. So basically you have services configuring other services, which is a very common thing. And we try to work a lot with stacked services, which simplifies our life usually. And then we have some other unrelated services, which are different instances as well. All right. So what I can do now is, with the ARC action, I can generate test cases for any number of test cases at once. So if I paste my preset of settings here, I can see that there's something already triggered in background, which is good. I'm just going to talk through this quickly. So service types is basically the service points in your system. So any service point that has services in it. You can actually CLI tab complete and you can see what service types you have. And you can use them just copy paste them into this list of service types. Then you have a setting for the CXTA environment, as I mentioned, where you can have your template for your environment. Then I'm choosing an output path, CXTM demo, where my files in my local system will be generated by this action. Then I have this CXTM server, which I have to specify. Then I have this CXTM script source setting. So either it's a Git type of workflow here, or the application-based one. So application meaning it's in CXTM. The source of this automation is in CXTM and not in Git. Now you can see that my automation finished, and it's generated some test cases. But basically, you can choose in this what project do I want to attach my files to, and what version of CXTA I want to be running. CXTA comes with new versions almost monthly, so it's good to test with different versions. Then you have some other keywords, like you want to add a description for your services, which will show up. You see this link and stacked services. It's something I just made up. And then you have the robot file name. Again, it can be anything. Then you can choose to have some pre-configuration, which will be captured from your current CDB. So you can give any XPath here from your CDB, which will be captured and then pre-configured as needed, right? So every time you run a test case in a pipeline, you may need to have pre-configuration which matches your current environment. So this could be anything from topology information or IP address configuration for devices or whatever you need to capture. And you can see there's a pre-config devices, and I can add any number of devices in this list, which then will be captured and configured inside your pipeline. So if you need to have IP addressing on your specific interface for this service to actually function, or any kind of pre-configuration like a VRF, which is always configured, an AS number in BGP, like any kind of pre-configuration you can think of, which you want to capture from your devices, to be able to apply your service successfully in the network. So you can kind of emulate the real network environment by having the real network configuration being pushed as a pre-configuration into your NetSim devices. Okay, so what happened in this action in the background? Let's see if this works. There we go. We have two separate test cases generated here.
Yeah, maybe let's clarify a bit compared
Yes.
to the previous presentation. So the test case, they exist in robot, and they are part of the robot definition, what they are. They're part of a suite, they can be part of a suite. And usually there are multiple test cases in a single robot file. In CXTM, we also define test cases as a single test that might contain one or more test cases in robot. Usually, again, is one single robot file that is pointing to a test case, and that is called a job file. So sometimes we'll call it test case, sometimes it's a robot test case, sometimes it's a CXTM test case.
Right. So what we have here is generated directly from my ARC action. So we can see there's a create service, stacked service, and we have a create service link. Okay, so you can see that there are attachments here, and these are basically all the files which are required to automate the test case and verify that it works. So you have a devices diff XML, which is basically the get modifications output from NSO, which is captured. Then we have a before and after CLI configuration. How that's captured, I will get into later. Then we have a before XML, which is basically the one which is used for pre-configuration. And then we have a pre-config for the CDB configuration, XPath, which I provided. If I look at this, I can see it directly here in the UI. So this is what I captured. Global settings. It can be anything which is required to be configured in your pipeline testing. Okay, so let's go back to the test case list. Actually, let's jump into the test case itself, and you can see we have a robot file here. And let's go to edit mode here to see it more clearly. So this is what I generate from my template in NSO-ARC. So basically we have a testbed file, we have all the variables required, we have some keywords which are specific for my NSO-ARC test cases. So those are all attached here, so I'm not necessarily relying on too many of the default test case keywords which are in robot or CXTA. So all of these are things which I attach. And now you can see the test cases here with the pre-configuration of NSO for the, let's see here, we have the before config for the device and also the pre-config we just looked at with the global settings, right? So those are pre-configurations. Then we have the capturing of the configuration and actually capturing the before configuration, the modification of NSO to add the service instance in the middle here. And then we have the capture of the after configuration for the device. And you can see here, because robot is quite clear, readable things, you can see that there's a specific way I'm capturing this pre and like before and after configuration, and that's actually using the live status execution of show running config on the device. So why do I do show running config on the device before and after? Obviously, because I don't trust the NSO view on the device configuration. Sometimes devices add dynamic configuration, which is not expected by NSO or not even covered by the NED of NSO. So right now the Cisco device configuration coverage of the NED is around 95%-ish of the entire configuration that the devices are capable of. So that leaves like 5%, which I can show you in the show running config, and I can see if it's actually generating something unexpected. So if your firmware of the device is changing, maybe this could generate some more dynamic configuration. Hopefully not, but you will be able to see that change with this show running config execution against the actual device. And then we check the diff set against what I captured, right? What is captured, the before and after CLI. So I diff the config before and after, and I diff what I actually capture in this robot test case. And then I compare the diff against the expected ones. What I captured with. So basically the diff set should remain the same depending on, even if you have a NetSim environment and you move to a real device environment, you may see that the diff set should not change much because it's more or less the same. So that's why it's most interesting to see only the diff set of your service and nothing else. And then we delete the service. Obviously, there are some nice features here, like if I run it against a pipeline, the service will not exist before I run this test case, but I can still run this on my local because I have these nice keywords here. Run if keyword service was present equals false, and then you delete depending on that. So basically, this whole robot file is built up in a way that it should leave the CDB in the same state as it found it, right? So if you have a local NSO and you have the service instance, you start off by deleting what you have. So you have this run keyword if, and you delete the service before you start testing the before configuration. Right? Yes. Yes, sometimes they will, yeah.
How do you prepare what you expect to get? Like, does it mean that each time you do this, you have to put the variables in?
No, I generate just what's coming from NSO-CDB. Whatever is in there as service configuration, I use that one. So if your service is generating an IP address from a pool, let's say, then you have to have the pool as a pre-configuration. So the setup of your IP address pool must be able to live in the pre-configuration capture, right? So you set up the pool in the same way in each environment, and then you expect the first IP address to be the same address every time.
Aren't you checking what is configured on the actual device?
Yes.
So if you configure a service that sets an IP on an interface, how do you know what the IP address will be? The endpoint column of that, or?
I don't follow the question.
The assumption is that you take it from NSO.
When he ran the command there that built the test case, it took the service, the path of the service, and stored that information as input for the test. And then you delete the service, you read the information that's on the device as without the service, and then you apply the service, and then you get the data. My assumption.
Yeah, thank you for that. Yes. So yeah, well, now what do we do with this? Let's try to run it. And I will just clean up a few settings here to make sure it runs properly. So I'm just running it now, and this is job file queued to run. Okay. So now it's working in the background. We can go and check out the other test case we generated. So let's look at our nanoservice testing. If you're familiar with nanoservices, you will know that nanoservices have something called zombies, and well, first of all, it has a service plan, right? So you want to check that your plan has reached the ready state or the end state. So basically, that's what we're checking with this keyword here. And if you have a zombie, obviously you want to check that there is no zombie leftovers. We want to find nothing here. So basically, we want it to be 404 as a response. So if we look at these validation test cases for nanoservices, we have these nice things like wait until keyword succeeds. So I'm waiting for something for maximum 5 minutes every second to check if this zombie state exists when I have deleted something. And then when I have modified NSO with a nanoservice, I need to again check that we have succeeded and get the correct state at the end. So those are some key points which I'm automating. Basically, I'm checking in my code if the plan exists for a service, and then I use these nice keywords here to automate it. All right, so Now let's queue this up to run as well. Okay, so let me go back to my project and we can see, oh, we have something has passed. Okay, obviously this being my local and I just generated my own test case, it should pass because my environment is the one I generated it from. Correct. But you could also run this test case now against any other environment this CXTM has access to and has topologies for. And if we look at the details here on the results, you can dig into those nice and nifty logs which Maciek in the previous session already went through. So you can see the pre-configuration being done on the device. I can check the pre-configuration is being done on NSO. I can see that I'm doing the capture with the show running config before we modify, we capture it after, and then we check the diff against the expected ones. And wait a minute. Do you see that? There's a typo. Oh dear. That's not good. Color. That's not what I want to see, right? So let's see if I can find my template. And I can go in here and correct it. Okay, let's write that one. Go to my CLI again. So I'm gonna redeploy the package, router static, redeploy. Okay, so now I've redeployed the package, which means at least since 5.6 or something in NSO versions, even the templates are being redeployed, which is very handy for me. So let's go back and let's go to my job file again. This is hopefully the right one, right? Yes. And let's go to save and run here. So I'm actually queuing up that job file again to run against my local. Now I can check if I have results on my nanoservice test case. How nice. Okay, so now I have my creation of my service and I can show you what happens when we find a zombie. You see that red keyword there? So what we're expecting to find is 404 as an output for this specific REST-conf call, where I'm looking for the ready status. So basically, if that status is still there, we have a zombie. As in, I've removed my nanoservice, but I still find it in the system. So nanoservices take a little bit more time than normal services to be removed because they have a kind of backtracking plan to execute before they are disappearing from the system. That's why we find this zombie. But 1 second later, we get the green light. We don't find anymore the zombie. So this is a handy keyword. Wait until keyword succeeds. There can be many things you want to wait for when you do your robot test cases, and this is one of those things. And then we have the validation stage, where I validate against the get modifications against this specific service. These devices are kind of sample NAD devices for basic netconf, which are created by the BU. They don't have CLI capability, so I cannot do show running config against these. So that's why we only validate what is the NSO worldview. Yes, you have a question?
Can we use Juno CLI or is it only
Junos is fine, yes. Juniper is validated with this. NSO-ARC runs against Juniper, yes. No problem. Yeah. So basically, every time I modify something or delete something, I always need to check for the either the reached state on the plan or looking for the zombie with deletions. Okay, so let's go back and see if my results are in for my other test case. What do you know? We have a failure. But in this case, it's not an unexpected failure. This is what I have, hopefully, the one correction I made. So I changed it from color to color inside the template, and then I redeployed it, and I run the test case against it to make sure. And you can see that there are two places where it fails now, because one is the show running config validation, and the other is the NSO worldview validation, where you have the get modifications XML output. So both of them very correctly show that I have changed something in my code, or template, or Yang model. And what do you do when you want to update the test case? Usually, you modify it manually. But in this case, I can just rerun my ARC action one more time. You have a question?
Yeah. So, like for the ARC to be able to generate these test cases automatically, your NSO service need to have a specific keywords or standard or a template?
Nothing. It runs on basically any type of service. I had some issues with some types of services, but I mean that was more on where they were augmenting into in the CDB. But otherwise, there hasn't been any problems with the type of test case we can generate for type of service.
Yep.
Oh, say 10 minutes left. Okay, good.
3.
So that's more or less the end of the demo. But basically, what I can also do, because this was a service type input, I can also do the same with all service instances. So what I will, so any number of service instances in your system can coexist at the same time. And sometimes to be able to run those in kind of in a pipeline environment, that requires you to have an empty environment before you run each and every test case. And that keyword is test in isolation. So test in isolation does some clever stuff in the background, deleting all other service instances from CDB, basically cleaning up what's in there before it is capturing the configuration of the specific service instance. And then it goes back and restores everything to the beginning state, goes and picks up the next service instance in the CDB, does it all over again, deletes all the other instances, captures the configuration, and rinse and repeat. And the end state will be that you have a very clean device capture for each and every test case, and it will always run perfectly in your NetSim generated pipelines, and hopefully also on your real device pipelines. All right.
So few words regarding everything that we saw today was we start with robot that is supposed to be easy to write and to read, but still some knowledge is needed. Now we have the automatically generated of the test. We need to have an environment where we run the test. In this case, if we set up CXTM, basically anyone can access via web UI and run them. Obviously, also the pipeline can connect. We have a REST API call for everything. And there is a visual representation of the result, meaning that also people that with zero technical background can know the actual status of all the tests that were run. We can add automated test cases that we saw, can be manual, that are still manual, that will be developed later on. And even non-technical people potentially can run. So there is just that button run it. Obviously, we need to give the permission or not to specific people, but that is the whole journey. And again, there is the CI/CD pipeline behind that can trigger it, and we will see also the story that everything that was triggered by the pipeline will be still captured in CXTM, and we can go back and check how things change or evolved during the time.